Well, hi, good morning. Thanks so much for joining me in my shop here on March 20th. Today what I hope to do is complete an entire alignment of this radio. In the last short video I posted on it, I changed a few capacitors, then ran the radio and diddled around with the alignment a wee bit, and the performance of the radio is really poor. So I'm pretty sure it's all alignment. It turns out, I think I commented on this sometime earlier, the schematic for this radio is highly detailed and very well done. Really nicely done. I should have realized, well, if the schematic's done well, I bet you the whole service manual is done well. So since then I have acquired the key pages from the service manual, including the alignment page here, and this interesting diagram, which is in fact the scale. And I've checked it. This scale exactly matches the scale on the radio. Excellent. So with these things in hand now, I can do a really good job at aligning this radio, and that's what I intend to do. So it's a very lots of words here, a description of how to dress certain wires and components underneath the chassis. I'm going to take a look at that, just make sure that everything's in order there. There appears to be a number of versions of this radio that were made, significantly different versions of it, different tubes, different circuits. There's 4 or 5 schematics. If you go on Radio Museum, I think there's 4 or 5 different schematics for this radio. So, but all I found was this one table, and I think it's probably true for all the radios, of how to align it here. And lots of instructions up here too. So we're going to follow through this very carefully and follow the instructions and hopefully restore the performance of this radio back to what it should be. This radio has a lot of tubes in it. Generally speaking, more tubes, better radio, generally speaking. It only has 2 sections in the capacitor, so it's not a super duper tuner, but nevertheless, it should be able to do a very good job. So I'm going to stop recording now and get the equipment set up for the first stage, which is aligning this transformer here. So I'm in the middle of getting things ready. One of the things I wanted to do was kind of hang this antenna up out of the way. Alright, discover just how sharp this one is. You have it slightly off. That's what you get. Poor performance. So some of what I was experiencing in terms of poor performance is probably just due to the antenna location. So I'm going to try to hang it up here. It's not too important during the alignment, but important when you want to judge how well the radio is working. I also noticed this. Seems better now. Okay. Everything is critical, it seems. Okay, so I have an output meter connected. There we go. And now with a signal generator and a few other things. Okay, I think we're ready here. The radio's on. I have the connection of the signal generator going into the grid, the 6 SG7 tube. So the output of that tube goes through the second IF, which is what I'm going to adjust, which is this one down here. And we're not hearing anything. So we hear it, but I don't have the frequency at 455 here. I've got it at, if you can read that, 4 31. Okay, got my hand on the volume control here. Beating with the station that it's tuned into. I'm going to tune the radio away from that station now. There. So all we hear is the tone. I'm going to back this down. Turn up the volume. Make our meter more sensitive. Uh-oh, we're just on the wrong spot here. Barely registering. Okay, we'll put a little more signal in over here. There we go. Volume's full on the radio. Let's see if we can make this go up. The meter. So I did this by ear last night. It's really cannot be improved. I'll try up here at the top. Seem to do anything. There it goes. No, it's good. Okay, now I need to move the signal generator to a different location than the radio. Carry on with the next step. To the 6SA grid in series with the capacitor. 6SA7. Find out what the grid is on a 6SA7. SA7. So it's a converter. It's got two grids. We need to know which grid. Sometimes there's a grid on pin 1 and a grid on pin 3, and different radios use those differently with the just looking at the schematic here. With whether the antenna goes to grid 1 or the oscillator goes to grid 1. In this radio, the antenna goes to grid 3, or pin 3. Am I saying that right? I'm not saying that right. So look at the third grid, pin 8. There it is there, G3, pin 8. Pin 8 is where we want to go. Okay, I'm going to turn the radio off because of my hands getting inside here when I'm doing this. The 6SA7 is this tube right up in here. And pin number 8. Okay, pin 8 is right here. Okay, we're on pin 8. Still at 455 from the signal generator. First IF transformer. This one up here. goofy slot here. There we go. Okay, watching the meter. Down, down, so it was just fine. I'll do the top. Okay, watching the meter now. Just a hair off. There we go. That's the IFs aligned. They were pretty good actually, the way they were. Really didn't make much difference there. Now we move on to connect the signal generator to the yellow lead on the loop in series with a 200 picofarad capacitor link closed. Yellow lead. So the yellow lead is this one, and identified here in this diagram. It says yellow. That's this guy here. Now, what are they saying? They're saying, they aren't saying, do you disconnect it from the antenna and connect the signal generator in its place? You just parallel it up to the antenna? They aren't specific. Yellow lead on loop in series with 200 picofarad. Well, I guess I could interpret that, you know, on loop means it's on the loop. It means it's connected to the loop antenna up here. And I should just, my clip lead from the signal generator either up there or at the other end of this wire, which is coming under here somewhere. Hard to say which one it is because they've all kind of gone to the same color over the years. We attach way up here, and then we go to 1400. Okay, let's try that. Did not say with a capacitor or anything, did it? Just disconnect it, keep the link closed. Looking for a good place to, here we are, right up here. Okay, so the IF frequency is getting through the radio. That's not what we're after. 1400. Oh, I've got to do the dial. And I think we're done underneath. I just have to check one. And yeah, we're done underneath. So I'm going to stop, lay this down, get it all set up for the next stage. Okay, yeah, great service manual. So I've cut this out. I think I mentioned I've checked this against the actual real dial glass, and this matches perfectly. It's the right size and everything. It says here, second reference mark on dial backing plate. And the instructions say, cut out the printed dial scale. With the gang at full mesh, the pointer should be set to the second reference mark from the left hand end of the dial backing plate. Second reference mark. So these are a little tricky to spot these. I had to hunt around a bit. They're right there for you to see. I think if I put a little extra light on, they'll come to life. There they are. 1 and 2. So this is the second mark here, and that's where this pointer should stop when I do this. Okay, and it's just a hair off. Really a tiny amount. Good. I think that's pretty good. Just move it a little bit here. Now it's right on top of the mark. Okay, now we put the dial plate in behind, the dial page in behind, and we line up this mark with the same thing. About like that, and then we're supposed to masking tape it in place. So obviously you don't want this moving. Although I guess you could be checking it over and over. I'll just put a little dab of tape on here. This is immensely helpful. Now some radios have a second dial located on the back of the plate to be used by during alignment, and others have marks. That's if they can't have the actual dial in front of it here, they have marks all across here, so you can spot the right frequencies. Some have those marks right on the glass in case the radio can be aligned. Sometimes the glass is fixed to the radio chassis, so it's there. They still have little marks, little indiscreet, little marks nobody would notice unless they're looking for them. Okay, so we're just a little over. I guess I should have checked it a little closer before I put the tape on. This is drafting tape. It's not very sticky. Okay, now that's lined up perfectly. Excellent. Okay, so the next thing is done at 14 kilocycles. I almost have everything hooked up, but not quite yet. Okay, I think we're ready to go here. Got this in place. Still have the meter connected. I have this camera you can see, and you can see the shot. So you can see the 3 screws here, and 1, 2. Maybe you can't see that last. Well, you can actually see it. Those are the adjustments I have to adjust. So we should go to 1400. And do C24. C24 is the middle screw. Okay, go to 1400 here. So unfortunately, there's noise there. So high. Just 13. It's even worse. About 1350. Hard to be precise. Well, let's give it a go at 1400. 1400. Probably in front of the meter while I was doing that. Still in front of the meter. There we go. give it a little more power over here. It's not going to work here. Too much interference coming from the antenna. Do I really need that antenna connected? Probably. Certainly doesn't say disconnected. So I'm going to assume, okay, we could do this maybe at 15. It's just noise everywhere in here. 1450. Even where there's no sound coming out of the speaker, there could still be an unmodulated noise signal sitting in there. So that looks pretty good. I'd say we're just a hair above 1450. I would say that's 1460 there. 1460. So the radio, yeah, that's much better. The radio thinks it's 1430. There's no chance of that. See the 15 dot is right there. Okay, that's definitely 1460. So that's what we're gonna aim for. 1460. We're adjusting the center screw here. I'm gonna try a metal screwdriver. Should be okay. Seems okay. Okay, go up a little bit here. Find it. So this is retuning the radio, so we could get into spots again where the noise is stronger than the signal generator. I should just turn this up even more here. Really settle the score. 60. That's 1460 there. It's like the meter's operating backwards. It's just a little odd. Is the volume turned up? Not that it should matter too much now. There we are. Okay, that's going to have to be satisfactory. Now we go down to the other end, 600, and we do the same thing, only this time we're adjusting L4. L4 is 1, 2, there's a third one back here, L4, 600. L4. That's L4. Get it in a minute. 600. Nice and quiet right on the 600 mark. 600. Oh, that's the IF coming through. So it's a little out. There's always a little bit of noise there. So we want to get it down to 600. Okay, put that in. Should be easy to find. 600. There it is. The meter is just not helping. Just doing it with my ear too. Maybe it's a sign of a very good ABC. right there. And move back up to the... We'll do this at 14 now. 15. No. Oh my gosh, I was looking at the wrong dots here. I've done this before in these radios. The upper dial, the shortwave dial, has similar numbers on it. 14, 16, 14, 16. I started looking at the wrong spots. Okay, let's try down here, Jim. That would be 14, 15, 14, 1450, 15, 1550, 1600. Doesn't really appear here. 55. This must. What's going on here? So they have big dots and small dots down here. Big dots and small dots. Like the big dots would be 600, 700, 800. Okay, so the big dots are marking the position of these numbers. Because if you 800, 700, 600, 500, no, 550. So the big dots go with the words. That's what they must be doing. There are two big dots in a row. Must be what's going on. So if that's the case, then we're looking at 10, 11, 12, 13, 14, 15, 16. So that's 16, that's 1650 up there. I think I can read the dial. That's always helpful in doing this kind of work. Always helpful. Okay, so we're on 1600 right now. That's not too bad. 1600. I'm looking up the meter. 1500. I want you to do it here though, but look at that. 13. That's also wiped out. Wiped out! 16 is not bad. Okay, doing it at 16. 16. I can still hear from the heterodyne that there's another signal in there. 16, we'll go back to the center capacitor. Right there. Back to the 600. So we're picking up 15, my signal generator at 1600. We're picking it up at... Okay, I'll just ignore that for a minute. We're on 600 now. Dial down to 600, up to 600. I'm looking at the meter, you can't see it, but I can. That's the top of the meter. 602, you know, that's the width of the pointer here. I'll make the adjustment. Okay, 600. That would be 600, watching the meter. That's pretty good. Let's check. We'll check right in the middle here at 1 million. Okay, 1 million. What do you get? So the scale is not linear. if we put this on a million, that's a million, and we'll find out where's that tuning at. So the question would be, can you find the station you want with this accuracy? I'd say so. No, it's just, yeah, I think that's going to be good enough. We'll fiddle around with this for quite a while, but we'll never get it to work perfectly. I often wonder if these ever did work perfectly when they come out of the factory. Okay, so we have done that. L4, I should have been rocking the gang while I'm doing L4, so let's go back to 600 and we'll do that. 600. Sometimes this has a big impact. It's a procedure that I've always kind of struggled with. That's reassuring. In effect, we're aligning three things at once. One of them, though, is fixed in place. And we're going to wiggle the other two until they line up with the third one that's fixed. Wiggle, this is hard to turn. So I got this other tool here, which is just a wee bit better. Okay, so what I'm going to do is I'm going to try different settings of the tuning knob and find out which one works best with different settings of this. So we're going to go up a bit, and then turn, up a bit more, up a bit more, up a bit more, a bit more. It's getting much better. We're way up the dial now. So we're way up the dial here. Way off. What did we have here? On the meter. I've got such a strong signal coming in, the AVC is active, I'm sure. So that's just a hair above 7 decibels on here. Okay, so we'll put this back to 6. Bring this back down. They're basically the same. As I say, I've always had trouble with this rocking thing. We'll go the other direction now. We'll go down band. Down a bit. I have had a radio that really responded to this. We just keep getting back to the same thing. Let's go up. Okay, put it on 6. Don't see that this is helping much. Doing this back once. But I did have one radio really made a difference. Okay. So I think that's the AM band aligned. So we'll see now what it's picking up. Disconnect the signal generator here. Lots of volume. .590 right in here. It's probably an antenna problem. Come on. see if I can twist this antenna. It's pretty tough with these wires here. Set any different. Here we are anyway. So 590 here in my shop. That's not too bad. There should be a 640 in here. Ooh, that's really. How about a 680? Just doesn't want to do it. 860. Such a sharp antenna. Oh my gosh. That's not bad. I think that's good. I think that's good. I like that French station for checking radios. The radio's working well, it can pick it up. And this one is picking it up, despite the fact it's here in my shop with everything else that's in here. Okay, now we're going to move on to the short wave. And their special instructions are there. Antenna terminal in series with a 47 picofarad capacitor. Oscillator, antenna adjustment. There's a, what's the star here? Use a minimum capacity peak if 2 can be obtained. So when you're doing these short wave bands, especially when you get up towards the higher end, you can accidentally align the radio listening to the image frequency instead of the real McCoy. Now in here it's already said that the local oscillator runs above the target frequency, the tuned frequency. So with that hint in mind, I have another approach I can apply here to help resolve where the local oscillator is and not make that mistake of aligning the radio accidentally on the image frequency, which in these radios with a 455 kilohertz IF, the image can be quite strong up here and easy to confuse them. And unfortunately, the image rejection capability of this kind of radio is very poor. So what that means is if you tune in 15 megahertz, okay, let's say you tune in 15 megahertz, you're trying to hear WWV, and if there happens to be a station 910, right, 910, which is double 455, 910 kilohertz up band, it may come through just as nice, just as if it's down here. So there's a element of a radio called image rejection, where that second signal can't make it through, and it's just not the case with a radio like this. It's never the case, I think. You need a double conversion radio, one that uses a higher IF frequency on the higher bands to spread out from 910 to some huge number. So the image frequency is way up band, and by then other tuning elements in the radio will have quelled it, squelched it, made the radio insensitive to it, is really want to say. Okay, so I'm going to set that up, including the way to take a look at the local oscillator frequency, and we'll carry on from there. Okay, so now in the lower right is my SDR. The SDR antenna is hooked up to this yellow clip lead coil just shoved in here, where I think there should be, the local oscillator should be floating around in there. So we'll switch this to shortwave. Okay, maybe not that way, how about this way? There we are. Oh. Looks like there's dirt on the switch here. We better attend to that before we go any further. Okay, darn it. Okay, switch off. I should have done that earlier, but saw no need for it. I guess one could guess. There's going to be a need for a band switch here. Just a few wafers. Dripping all in there. Bit of oil in that. Okay, that's probably going to make a big difference there. Let's find out. Good. So that was the broadcast. This is shortwave. There we are. Still a little bit wonky. Good. Now you can see on the SDR there's more than one line coming down. And why are we seeing nothing up here? Not exactly sure. There we go. That's a little better. Okay, so this is probably the local oscillator here. I'll tune the radio. We'll see if it moves around. Oh my gosh, look at all those things showing up. Where'd it go? Oh, there it is. There's the real McCoy. Now, my SDR, I think like all these SDRs, they aren't the greatest radio, and when you overload the input, which I think is happening now, you get lots of ghostly things happening. But this great big signal here is the local oscillator. So if we tune the radio to 15, yeah, 15, get on the right band, Jim, don't make that mistake. That's 15. We should add 455, and the oscillator should be right in this area. And we're tuned to 15, and 455 above it. Wow, it's just a mile out. Okay, I'm going to set this red line on 455, on 455. That's where the oscillator should be. It is 15 miles out. C23 is what we adjust. C23 is the one at the back. The one at the back. That's this one. We'll just watch the SDR and see if that comes into view. Not that way. Maybe this way. There it comes. That's supposed to be down by the red line. This capacitor was tuned way open. Way off. So in fact that's really what needs to be done to do the alignment. I don't really need to check the meter, but let's do that. 15. So I have to set the signal generator onto 15 and see how well this worked. Not a thing. How can that be? Signal generators on the shortwave antenna. Okay, something bad is going wrong. What am I not thinking of? Let's hunt around a little bit. That's just nothing. Get a little more juice. Wow. Why so weak? so weak? Maybe I'm on the wrong. I don't think so. I'm on the antenna terminal. It marks it here. It doesn't actually mark it. So, but I'm pretty sure it has to be this one here, the one I'm on. Why so incredibly weak? It's because I'm making the mistake that I'm trying to avoid, and there's another oscillator. Let's slide around the Sdr and go looking for another big thing. Maybe up here? It's way up here. It's not as big though. So back down here. So go 900 down, so that is roughly 14,400. 14. So there it is there, probably, yeah, 14,400. But it's smaller again. I'm pretty sure I got the right local oscillator. It's not quite the right way to put it, but 14,455, 15 megahertz. Did I read this dial wrong? 14, 15, 16, how could it be wrong? Figured out how these dots work. Why so weak? So I'm sending over a, it's a weakish antenna signal, but any good radio would receive this quite well. Maybe with a bit of noise like you hear now. If I give it the strong antenna signal. It's very poor. A lot of noise coming through. Why do you like this? Let's carry on, see if things don't straighten out as we go. Oh, it wants to do an antenna adjustment now. C20. Maybe that's the problem. Okay, we'll do C20. Maybe that's the problem. C20. Oh, could be. Yep, that could be the problem. Better. That's much better. Okay. We'll go to the other end of the band and do a couple more things. 9.5. We'll go to 9.5. 9.5. Where did it all go? So this is 10. This is 9.3. That's a crazy dial. This is 9.3, and there's the big dot. You're supposed to do 9.5. Why did we do this here? 9.5. So would that be 9.5? This would be 9. 9.3, 9.5. Must be the case. Well, we can look at where the local oscillator is and we can judge something. So if we're tuning in 9.5, local oscillator 455 above, 9.955. Let's look on the Sdr and see what we find at 9.55. 4555, something like that. So something big over here. That's got to be 9.5. So 9.5, 9955 is where it should be. 9955 is over here. Right there. Is that the local oscillator there? probably it. So we'll put this back on 9.5. We'll drive the oscillator frequency downwards with what? With L5. L5 is L5 is the one in the middle. Okay, we're on. Watch the SDR and drive down the little oscillator down to the red line. It's kind of curious. We heard something there. Do I not have this? Oh, I don't have the other. I don't have the signal generator set. 9.5. So we'll dial this to 9.5. It's right at the end of the scale. Come on, you can do it. No, you can't. Come up this way. That's right where the scale, the bands change on my signal generator, and sometimes has trouble oscillating. Okay, 9.5 coming. Lovely. That's it. Lovely. The dot is right under there. Good. That's good. Go back up to the top. Do that again. Oh, there's another one. Antenna, L3. L3 must be the last adjustment. L3. The only one I haven't turned. Watch the meter. Top. Wow, there's some bad interference there. What is that? So this would be 15. And go right to 16. Let's go to 16. To 16 megahertz. Okay, that's where I think I am now. 16 megahertz. Not as sensitive as the other end. Just a little off. Megahertz. Close enough. I don't want to make a mistake at this point. So at 16 megahertz, doing C23, which is very close now, so I don't have to worry about the image. C23, top one here. I think we can do it like this. Like this. A little bigger screwdriver here. More control this way. So 16 at 16. Do the antenna. Don't make a mistake. C20. This one here. Okay. back down to 9.5. Wow, what is that? I'm so quiet down here. Okay, just fooling around. 9.5. Okay, we're right on 9.5. Whoa. Turn this down. Very close. How far out is that? Okay, it's out by a bit. Read the instructions. L5. L5 in the middle. Running a signal high enough to trigger the AVC, which I'm almost always doing. You just have to be very vigilant while you're doing this for the AVCs throwing things up and down a little bit. So you have 9.5 there. That's really kind of the end of the road. Let's put an antenna on this and see what we can get with a real antenna. Hunt it down. This is it here. Did I turn the volume right down? Okay, that's one lead. Yeah, I did. Okay, now there's usually a strong signal at 9.3. 9.3 happens to be marked.
Against Cuba. 60 years now? 70? Yeah, it's virtually bankrupted the country, so yes, it's impossible to impose no cell laws and enforce them.
There's a very, very low bass in their voice, and it's causing the speaker to rattle a bit because it's just sitting loose on my bench. So the low frequency of response is fantastic. Volume? Almost no volume up. Excellent. This is a very strong signal. Now let's see what else we can find. Anything else? Not. It's strong and it's also local in that it's North America. Let's head up to lots of funny things on the SDR. Right? Let's head up to 25 meter band. There we go. I usually pick up two, I think it's Radio Marti, twice on here. Tone. Pick it up again. Now, depending upon the radio conditions, since this radio was made, these shortwave bands have expanded. So you'll find shortwave broadcasts outside of the band markings. Like that one. There's this wild noise. What could that be? I don't know. Let's just get through it. What have I got going in my shop today that's doing that? I have no answer for that. Oh, this is it here. Yeah. So, interestingly enough, I have these LED lights because this is our radio shop. This is of interest. I have these LED lights. I'm running them from a little variable power supply up here. If you overdrive the lights, this is what you get. There's probably a voltage limiter or a circuit of some sort inside the light, and when you try to give it too much voltage, it's probably bleeding off some power, and it's doing it in a crude way and producing that. So we've been listening to that. Well, I think it's just contained right in this area. So let's see what we can get now. This is a European shortwave band. There's usually stuff on it. It's noon. It's 1/2 noon here. No, nobody home today. Let's go a little higher. This is another band, 19 megahertz. WWV should be hanging right around here, but we're not likely to hear it. There's a strong signal up here at 15,770. We might get there. Nope. Turn slowly through this. I have two outdoor antennas. I maybe switched on the one that's less satisfactory. Don't think I am, but I don't know offhand. So there we go. So the radio's aligned under different location, different circumstances. It's going to work better. There are instructions in here on utilizing the antenna that's a piece of wire wrapped around the inside of the console cabinet. And the instructions are, I'm not going to read them here, but to make another adjustment, I believe it's this one. If you're going to use that antenna, you should go in and adjust that. Yeah, so from here it's going back in its cabinet. Install and connect chassis in cabinet with link closed. That's this tuning link back here. Tune in a radiated signal of 1400 on broadcast band and peak C32 on the loop. So we do this one when it's back in the cabinet for the station tuned in. Maybe that'll improve the AM performance. So there we go. It's all aligned. Good show. Okay. I got a big job putting this back in the cabinet. Thanks a lot for watching, and I'll see if I can manage to shoot a video of it back in its cabinet operating. We'll see how that works out. Thanks a lot for watching. See ya.